you, this is like the trick stuff. And then I'll show you next time stuff that how we show stuff with limits, properties about it. So in the undergraduate reals book, you start off with some like preliminaries with, you know, stats and things. We're going to skip that in the actual real analysis. I'm not going to do that because it's super boring. And so we'll learn it on the way if there's a gap. But in the first actual meat that you get to is something called the triangle inequality. And it seems so simple, but you use that inequality all the time in the beginning of reals class. And what it looks like is, so first of all, absolute value becomes really important. It's a piecewise defined function. And if you want to prove something with absolute values in it, you have to go back to this. So I think that's the first wake up call. Like everybody kind of sits there for a while and it's going to happen. Like I've taught that class so many times at the beginning of class, everybody kind of yawns when I put this up on the board and they don't take notes. They're like, absolute value is 3 is 3. Absolute value -3 is 3. I know what that is. But you have to use something that you can get your hands into and work with. And so you have to use the definition, and this is the formal definition of absolute value. It's positive x if x is bigger or equal to 0, and it's the negative of x if x is less than 0. So if you have x is negative, like -3, slap on another negative in front of it, and it becomes +3. So that's the formula of absolute value. So you need that first, and then you're going to get this thing called the triangle inequality. And the way you prove that is by using the definition of absolute value and case by case. Basically, it's that if you have a triangle, then the adding up the sum of the lengths or adding up the two lengths on the side and taking the absolute value is going to be less than or equal to the absolute value of each thing by itself. If you think of that diagonal that takes you down to Arvin, that's the shortest path between Thayer and Arvin. You wouldn't, if you wanted to go instead, these are the things I think about on my way to Arvin. So if you wanted to go, for example, through Bartlett and then go up and then you're doing the other side. So this part here is that diagonal with use poop. That's that one, and that's a smaller distance than going around where you guys go in formation. That's what it is. Okay. So then you prove all kinds of stuff about it. So I'm going to do one proof and then send you to boards for a little while. And then we'll do boards also next week. A lot of boards. I'll come up with problems that you can do on the boards.
Ma'am, is this sheet going to be due next week?
Yeah, let me see how much I can get through. And then if you guys don't have time to finish it this week, we'll finish it next week. I guess we can go with gray, right? So these are what the proofs look like in real analysis. So if I want to prove this, I'm gonna do this. I'm gonna add what we call adding a zero. I've not changed anything. I've just added a minus b and then added a plus b. So those two things are the same. Very first student I ever had that did research with me at West Point in 1997, 8, Chris Perry, just retired from the Army. I kept telling him add a zero and he would just stare at me and go +0 and then stare back at me like, then it dawned on me like this is a trick that we see, and he had no idea what I was talking about and thought I was completely insane. But now I have this by triangle inequality is this. There's some things that are just burned in my mind. I just remember him looking at me like +0. Like, no, add a zero, like subtract it and add it again. Why would I do that? So they can use triangle inequality. There you go. Now I'm done because I just subtract the b from both sides. Check. They're pretty if you know the trick. If you don't know the trick, like this is one of the classes where the professor does all the problems on the board and then like, oh, that seems easy. And then you go home and you have your own homework. Like, I can't do any of the problems. I can just rewrite the problem for you. That's it. Because there's like a trick for every single one of them. I don't want to scare you from taking real analysis because I've done quite a bit and I know all these things. I got enough feedback from students. So I know where the hangups are going to be. And I've figured out how to kind of like guide you through that. It's a really good class to take.
Pause, like, so like, does that mean the absolute value of
Any real numbers.
a plus b, you can just distribute the absolute. You know, like the absolute value of a minus b, in parentheses plus b, you can distribute the absolute.
Well, that's triangle inequality, right? The triangle inequality says proof length, right? This is a new A, and this is a new B, and you just go back to triangle inequality, which I just gave you, and apply the triangle inequality to each one.
That's just the corollary.
This is like a result that comes from application of the triangle.
Alright.
See it?
I see.
All right, one more. Stay with me. This is a hard class. You also use the properties of absolute value, that the absolute value of negative x is equal to the same thing as absolute value of x. I like working with absolute values because I make a lot of sign errors. And so in absolute value, you can't make a sign error. So number 2. So this is triangle inequality. Done. It always makes the real analysis proofs always make sense too. Like when you watch it, I think that's the hard part. It's just you can't just because you watched a whole bunch of them doesn't mean you can do them. But you get better and better at like if you do it in a real analysis course, you get better and better at doing these proofs. Make sense, all of this? Is numerical are you guys taking numerical right now? Anybody taking numerical? I thought Colonel Lindquist was teaching you. Is he? You forgot? He probably used triangle inequality to prove some of the things. Did he do anything like this? That class should be full of inequalities.
I think I was.
When you guys found error for stuff,
We do found there.
Yeah, we do
it's all inequalities. So he might just be using it in there quickly,
You might be,
or he might not be proving anything in there. He might be programming.
yeah. So for. That one you did the triangle inequality.
Right.
You just substitute.
Substitute it back in.
That's probably.
I anticipated Josh's question and I the applying triangle inequality here and then substitute it back.
I don't think I'd like you can really run full spread. Maybe this guy, that makes sense.
Numerical is I took so many numerical classes after my first course in real analysis. And we proved stuff like there was boundary conditions, like if you have boundary value problems, you think you have more information, like you have to have it start here and stop here. So you got more information at the boundary points and an initial condition. Those problems are actually really hard to do numerically. Because you have to force your function to go into start here and stop here. And yeah, you don't get uniqueness of solutions and stuff, so you have to prove stuff about it first. But it's useful. I took so many classes and I feel like I've learned so much from that. Okay, any questions? Do get started choosing your problem that you want to do so that you know at least what you want to start doing. I give you the minimum deadlines. Don't wait, because if there's 10 people choosing the same problem, you'll come up and you'll be the 10th person. I'll say you can't choose that problem. So choose early, choose something you really like. Compared, that you should like the thing you're working on. And it helps so much more if you like the problem you're working on.